CCI, Crash Course Instrumentation, presents Saturday History, Special Episode Number 16, Pascal's Law and the Pressure Pioneers. Open, hook plus promise. Could a thin pipe and a little water explode a barrel? That legend is tied to Pascal's Law, the rule behind car lifts, shop presses, and the gauges on your plant floor. Today we will race through the pressure pioneers and show how their ideas became the instruments we touch every day. Special thanks to Tony Coupalt and the open source community. Our lesson draws on Model materials and is used under Creative Commons. Cathy, Section 1. What pressure is, in plain English. Pressure is how hard a force pushes on each bit of area. Say it in words. Pressure equals force divided by area. 1 Pascal means 1 Newton of force on 1 square metre of area. In liquids at rest, deeper points feel more pressure because more fluid is stacked above them. Section 2. Torricelli weighs the air, 1643. A tall glass tube with mercury flips into a cup and leaves a space at the top, a vacuum, and the column height changes with the weather. That simple mercury barometer proved the air itself has weight and set off a century of fluid experiments. Section 3. Pascal proves pressure falls with altitude, 1648. Pascal asked his brother-in-law to carry a barometer up a mountain and read it at stops along the way. The mercury level dropped at the summit, showing less atmosphere above exhales less pressure. That made air pressure a measurable thing. Section 4. Pascal's law, stated simply. Pascal's law. In a sealed, still liquid, any pressure change is passed on equally to every point and to the container walls. Say it without math. Push here, and the extra push appears everywhere in the fluid. That is why a small piston feeding a big piston multiplies. Force. The pressure is the same in both, but the big piston has more area, so the output force is bigger. Section 5. From law to muscle. The hydraulic press, 1795. Engineer. Joseph Bramah built the first successful hydraulic press. A small hand force on a small plunger lifted enormous loads on a big ram. Every shop jack, car lift, and crimper you use is a direct child of that idea. Section 6. Vacuum drama. Guericke's hemispheres, 1654. 2 metal bowls were pumped empty, and teams of horses could not pull them apart because outside air pressure squeezed them together. It is a showy reminder that pressure differences do real work. Section 7. Gas pressure gets a rule, 1662. Boyle's law says if you squeeze a fixed amount of gas to half its volume at the same temperature, the pressure doubles. This turned pressure from a curiosity into a predictable quantity, perfect for making instruments. Section 8. Flow turns pressure into speed, 1738. Bernoulli's principle. Where a fluid speeds up, its static pressure drops. That unlocks flow instruments. Pitot tubes compare moving pressure to still pressure to read velocity, and Venturi tubes read flow rate from a pressure drop. Section 9. The first pressure instruments you can build. U-tube manometer. A clear tube with liquid and a scale. Connect one side to a process and watch the height difference. Blood pressure, 1733. A long glass tube in an artery gave the first direct readings, crude and not humane by modern standards, but foundational to medical instruments. Section 10. Industrial workhorses, 1849. Bourdon tube gauge, 1849. A curved metal tube straightens slightly as pressure rises. Levers turn that motion into a pointer you can read. Deadweight tester. A piston and known weights generate precise pressure for calibrating gauges and transmitters. Section 11. From metal to silicon, 1954 today. Piezoresistive effect in silicon, 1954. Stretching a doped silicon element predictably changes its electrical resistance. Micro-machined silicon diaphragms and strain bridges became tiny, accurate MEMS pressure sensors used in cars, process transmitters, and smartphones. Section 12, the barrel legend, and what it teaches. You may hear that Pascal burst a barrel by adding a tall, thin pipe of water. The story is debated, but the lesson is sound. In a connected liquid, a small amount at a great height can create a large pressure at the bottom. That is Pascal's law in one picture, and it is why we respect head pressure in tanks and piping. Section 13, quick instrument connections for techs. Barometers and manometers turn pressure into height. Bourdon gauges turn pressure into pointer motion. Differential flow meters, pitot, venturi, turn pressure differences into speed and flow. Deadweight testers create reference pressure for calibration. MEMS sensors turn pressure into tiny resistance or frequency changes you can digitize. Section 14, 10-second recap. Torricelli showed the air has weight. Pascal showed pressure falls with altitude and spreads equally in liquids. Guericke dramatized vacuum. Boyle and Bernoulli made pressure predictable. Bramah and Bourdon turned ideas into machines. Silicon made it pocket size. Outro, CTA. If this helped, tap like, subscribe, and share with a classmate or co-worker. Tell us which pressure instrument you use most on the job. Special thanks again to Tony Coupalt and the open source community.